Topic 7a, Vulnerabilities and Threats. Vulnerabilities are flaws in systems that allow them to be exploited. They provide a means for attackers to compromise host servers and networks. Vulnerabilities come in two flavors. The first are software bugs, programming mistakes, errors in code that could cause a system to hang to an insecure state or allow root access. For example, incorrect firewall, router, or IDS rules. Second flavor is flaws from improper design. This is failing to account for all possibilities in design, which leads to codes with vulnerable features. Bugs may result from improper translation of specifications into code. This is why design specs should be detailed. Flaws can result from coding shortcuts, such as failure to validate inputs that are to be combined into scripting commands. Managing vulnerabilities is a two-edged sword. When you publish vulnerabilities and patches, this is the only way to fix the problem. However, once published, the network of hackers becomes aware of the vulnerabilities. Patch management is a major security problem. A zero-day vulnerability is a new or unknown or unpublished vulnerability. Good security management requires good patch management. Security by obscurity happens when an organization attempts to use secrecy to prevent knowledge of vulnerabilities in their software. Vendors of proprietary code are often accused of this. A zero-day attack is an attack that takes place during the window before a patch is available for a vulnerability. However, security by obscurity simply guarantees that customers are unaware of vulnerabilities in their systems. Ignorance is bliss. So what do you do if you discover a vulnerability in a product and a patch is not available? Do you keep it secret until a patch is developed? This leaves customers vulnerable. The vendor may not work to fix it since there is no pressure. Or do you publicize it to put pressure on the vendor, knowing that by doing so you have notified all of the hacker community? This is a major ethical issue because you find yourself between a rock and a hard place. Example number 1. In 2009, Microsoft announced vulnerability in server-based message subsystems that could leave servers vulnerable to denial-of-service attacks. There was no patch yet. IT managers had two choices. They could either disable SMB, meaning some systems would not work, or they could wait for a patch and pray that there would not be an incident. There was no easy solution. A few months later, a patch was developed and released. A second example. In 2008, a Massachusetts district judge ordered MIT students to not present information at DEF CON regarding a vulnerability in the Boston MTA Charlie ticket system. The judge said the intent was not to silence the students, but to enforce a reasonable period during which a fix could be found. The gag order was overturned, but not until after DEF CON had concluded. DEF CON, by the way, is one of a number of hacker conferences. Others are 2700, ShmooCon, and Black Hat. Most attendees of these conferences are security professionals, because you must understand how to compromise security in order to enhance it. There are many strategies available for managing vulnerabilities. These include vulnerability scanners, vulnerability notification, vulnerability information online through CERT and other groups, and vulnerability and penetration testing services. These go hand in hand with adequate patch management. Patch management requires policies, procedures, and documentation. IT budget should account for patch management. It is not strictly a security issue per se, It is a vulnerability issue. There are a number of programs that can scan a network host or application for known vulnerabilities. For example, port scanners that look for open ports, network enumerators that provide information on groups, usernames, shares, and services, network vulnerability scanners that look for vulnerabilities in network resources and servers, web application security scanners that look for vulnerabilities in web servers and scripts, and database security scanners looking for vulnerabilities in database management systems and SQL code. These tools can be used by security professionals. They can also be used by hackers. Many vendors will either mail a notification or post to a website when a vulnerability has been found and how to patch it. Services exist that maintain vulnerability lists for multiple products and will provide information. With many of these, you provide a list of the software and versions in your organization. In some cases, the list is proprietary, but few vendors make use of digital certificates or other methods to prevent unauthorized users from getting access to vulnerability notifications. Here are a few examples: Viewpin Security Vulnerability Services, SecureNet Solutions Vulnerability Notification Service, and Secundia CSI, which is a free vulnerability scanner for home users of Windows. CERT, the Computer Emergency Readiness Team at Carnegie Mellon University, provides weekly lists of known vulnerabilities for many popular pieces of software. The organization security team then matches the inventory of software in your organization and versions to these lists. CERT is currently a division of the U.S. Department of Homeland Security. This slide shows a segment of the weekly vulnerability list from CERT. They also publish source and patch information and a CVSS score. As an example, the CERT vulnerability summary for September 12, 2011 listed 48 high vulnerabilities, 12 in Adobe Acrobat, 7 in Microsoft Office, 2 in Microsoft Windows, and 2 in Google Chrome. 11 of these involve buffer overflow. 5 involve SQL injection. All allow attackers to execute arbitrary code, and this is a very, very bad thing. And all have patches available. Let's take an example. Vulnerability in Microsoft Office with the code number CVE 2011-1982. Certain versions of Microsoft Office do not initialize an unspecified object pointer during the opening of Word documents. This allows a remote attacker to execute arbitrary code via a specially crafted document. It has a CVSS base score of 9.3, which means it's very high, an impact subscore of 10, meaning the impact is the maximum, i.e. root access, and an exploitability subscore of 8.6, meaning that it is easy to craft an exploit. A little more information is provided, for example, the access vector, where it notes victim must voluntarily interact with the attack mechanism. In this case, it means opening a Word document. Access complexity is medium because it requires someone to open the Word document. Authentication is not required to exploit, and the impact allows unauthorized disclosure of information, unauthorized modification, i.e. running arbitrary code, and disruption of service. In this case, the problem is poor design. The product does not validate or incorrectly validates input that can affect the control flow or data flow of a program, in other words, taking over the program. A full list of how this happens is available from CERT. Threats are the counterpart to vulnerabilities because they exploit vulnerabilities. For example, a vulnerability, you left your car unlocked. The threat is criminals going through shopping center parking lots looking for unlocked cars. Fortinet's FortiGuard Center Threat Research and Response Center provides threat reports and advisories. A threat is not of interest if it is not currently being exploited. So awareness of the threat landscape can help to prioritize your vulnerabilities. I will now illustrate the top 3 application vulnerabilities. These appear quite frequently in CERT lists. The first one is the buffer overflow. This happens when software does not enforce array bounds. It can allow buffers, which are basically arrays used for input and output, to overflow and overwrite code area. Some malware works this way, as we call smashing the stack. It's mainly aimed at systems that allow code to be executed with privileged rights. It's best addressed in design and programming, and patches can often fix this in vendor-supplied software. Check the link at the bottom of this slide for a very simple example of a buffer overflow. This diagram shows an example of how a buffer overflow might work. It takes advantage of the fact that all memory is a large array of addressable spaces. Within that array are code spaces and data spaces. When buffers, data spaces, can be exceeded, one can write into the code space and execute arbitrary code. Cross-site scripting is a particularly insidious attack where code is injected into the communication stream between a web server and web client. Most drive-by malware attacks use this method to illegally download malware. It often relies on social engineering to get the user to follow a link to a specific server. Web scriptwriters can validate input and cleanse output to prevent this attack from happening. You can also disable scripting, although that's not always practical. And finally, the use of a least privilege account for your client prevents many forms of cross-site scripting. This slide illustrates the simplest form of a cross-site scripting attack. A malicious link is created to a website that will download malicious software. It assumes the user has administrator privilege. You send them an email telling them they've won free tickets to the Super Bowl. They have to click on a link to enter their information and claim their prize. When they click on the link, it requests the malicious page, and the malicious script is downloaded in the background without the user's knowledge. It is then run. The user is owned. SQL injection is by far the simplest form of attack on any system using an interface to a database management system that runs using structured query language. Commands are basically passed through a web form to SQL DBMS. When you inject SQL code into the stream, you can exploit a lack of security and gain control of the server. The solution is for the server to add code to validate input. Follow the link to the YouTube video on this slide for a simple example of a SQL injection attack. Consider the following SQL code. Select name from users where name equals parameter name and password equals parameter password. In a case like this, if you were to enter the script or equal as name, it will always generate a true condition. The solution is to check the input for special characters before passing the string to the SQL engine. Gartner defines 6 steps for vulnerability management. Define policy, baseline the environment, prioritize vulnerabilities, mitigate vulnerabilities, and maintain and monitor. Patch management requires coordinated effort, knowing which patches are available, testing the patches, and scheduling patch installation in a way that it has the least amount of impact on the organization. However, many systems still remain unpatched. Some applications, such as Firefox, will push patches to users. Other applications, such as Adobe, allow users to decide whether the patch is installed or not. Although recognized as a major security problem, patch management is seen as a burden by traditional IT management. It sucks up resources and it adds nothing to the bottom line of the organization. In summary, vulnerability management is mainly an issue of sloppy software system development and sloppy management of IT. IT budgets need to reflect the proper maintenance of systems. This includes vulnerabilities and patching. IT development budgets need to provide for security as part of the system development lifecycle. Security staff can help with penetration and vulnerability testing, prioritization, policy development, auditing, and so on.